Hello, everybody there who's watching. Today we are going to discuss the famous Einstein's equation of relativity, namely the time dilatation equation, and how to derive it in the simplest manner as possible. I've taken my hints from the book written by Tony Rothman and used his illustrations to derive this equation. So please pay attention. So here we will look at a train that is moving at a velocity of v like in vector, and it has a clock which is made out of a beam of light which is reflected by the two mirrors up and down. And so the time taken, 1 unit of time equals 2 LT. And if you look at the same thing down here, which is more magnified, this will be the beam of light that goes up and down, and the observer on the train observes the bouncing of the light twice and counts it as 1 unit of time. But the observer outside the train, who is looking at the train or vehicle pass by, looks at this particular beam at a little different angle. And if one looks at this, it is really a right angle triangle, the hypotenuse being this and the base being this. And so that we could say that the hypotenuse observed by the person on the ground would be CG TG divided by 2, and the person who is observing the beam on the train would look at LT equals CT multiplied by TT, where C stands for the velocity of light. And of course CG stands also for the velocity of light as observed on the ground. Now the train is traveling at a speed of v like a vector with that velocity. So x upon 2, this distance, would be equal to vtg divided by 2, and then we can look at this right angle triangle, and the hypotenuse will be equal to the base plus the square. The square of the hypotenuse will be equal to the square of the base and the square of the opposite side. So we will get CG square TG square upon 4 equals CT square TT square divided by 4 plus V square TG square divided by 4. And this will represent the Pythagoras theorem or equation for this particular triangle. But as you can see, that 4 seems to be a common denominator which will cancel out, and that will give us the next step, which will be the same as the previous one, except there will be no 4 in the denominator. Then we can transfer this particular entity to the opposite side, so that will make it CG square TG square minus V square TG square equals CT square multiplied by TT square. We have not denoted if v, the velocity, is on the ground or on the train, because it will be the same for the observer on the train as well as the person on the ground. So that will bring us to the next set of steps, which will remain the same on this side, but on this side we can take the tg square as a common factor between these two entities, and we can also get cg as a common factor, but then that will make us divide this side with c square. We know that ct square and tg square would be the same, because the velocity of light is the same for all frame of references where the speed is uniform between the frames. So that will give us the following step, which will be tg square tt square in brackets 1 minus v square divided by c square, brackets completed, equals ct square tt square, and that will give us the next step, and that will be tg square equals tt square divided by 1 minus v square divided by c square, and you can get a square root of both sides, which will give us the time dilatation equation. Tg equals tt divided by square root of 1 minus v square divided by c square. So this is the famous time dilatation equation related to the theory of relativity, which can be in a very simple way derived. I looked at the derivation in the book written by Einstein, and it was hard to follow his steps, and there were confusing steps, but this is a simple derivation. Thank you for your attention.